welcome to LearnCity. My name is Praise, and in today's class we'll be starting a whole new topic on probability. What is probability? Probability is the branch of mathematics concerning numerical descriptions of how likely an event is to occur, or how likely it is that a proposition is true. I repeat that again. Probability is the branch of mathematics concerning numerical descriptions of how likely an event is to occur, or how likely it is that a proposition is true. The probability of an event is a number between 0 and 1, where roughly speaking 0 indicates the impossibility of the event and 1 indicates the possibility of the event, where we can also say that 0 indicates uncertainty while 1 indicates certainty of an event occurring. Now, the higher the probability of an event, the more likely it is that the event will occur. An example is the tossing of a coin. Now, we all know how a coin looks like. A coin looks like where we have the head and the tail. There's a probability that when tossing the coin, we have a head, and there's a probability that when tossing the coin, we have a tail. So the probability of it being an head will be 1/2, and the possibility of being the tail will also be 1/2. Now, the possibility of getting an head and a tail will be 0, because it is not possible for a coin to be tossed to have two sides at the same time. Another example is the throwing of a dice. A dice is two different die. Now, when throwing a particular die, which is a single die, we have 6 different faces, where we have 1, 2, 3, 4, 5, 6. And when throwing dice, we have 6 different faces in 2 places. So we have possibilities of throwing a 1, a 2, a 3, a 4, a 5, and a 6 when throwing a die. Now, under probability, there's something called experimental probability, where experimental probability is the number of required outcomes over the number of possible outcomes. Also, we have theoretical probability, where theoretical probabilities are exact values which can be calculated by considering the physical nature of the given situation. Theoretical probabilities are exact values which can be calculated by considering the physical nature of the given situation. For instance, the given situation, where the probability of getting a number when a fair 6-sided die is thrown is 1/6. What am I trying to say? That the possibility of getting a 2 when throwing a die is 1/6, since any of one of the 6 faces is equally likely. So this is an example of a theoretical probability. And in today's class, we'll be checking examples under probability. The first example is Jesse throws a fair 6-sided die. Jesse throws a fair 6-sided die. What is the probability that she throws a 9, a 4, a number greater than 2, an even number, or either 1, 2, 3, 4, 5, 6? So, Jesse throws a fair 6-sided die, which we have 1, 2, 3, 4, 5, and 6. Now, what is the probability that she throws a 9? The probability that she throws a 9 is 0 or null, because a die has 6 faces. It does not have a face that is going to 9, and it is not a dice, it is a die, which is just a single entity. It is a single entity. So we're throwing a 9, it is not possible. Now, what is the probability that she throws a 4? The probability that she throws a 4 is 1/6. because 4 is thrown once. So the probability that a number is greater than 2, we have 1, 2, 3, 4, 5, 6. Now the probability that the number she throws is greater than 2 will be 3, 4, 5, 6, which gives us 4/6, where we can easily write it to be 2/3. That is the probability when she throws a number greater than 2. Now the probability of throwing an even number. The probability of throwing an even number. We know that even number are number which is divisible by 2. So in 1 to 6 we have 2, 3, we have 2, 4 and 6. So we have this to be 3/6, where we can also have it to be 1/2. So the probability of throwing an even number is 3/6, which is 1/2, since we have 3 different even numbers in the numbers available. Now the last one says either 1, 2, 3, 4, 5, 6. Either of this number is 1/6. So either of throwing this number is 1/6 for each. So for either of the 6 numbers, we now have it to be 6/6, which is 1. So the probability of throwing either of those numbers is 1. Now moving to the next example. A letter is chosen at random from the alphabet. Find the probability that it is F, it is either F or T. The third one says one of the letters of the word frequency, and D, not one of the letters of the word table. Now to solve this, we have that a letter is chosen at random from the alphabet. So we have alphabet to be A to Z. A to Z. And we know that the number of the alphabet is 26. We have the number of alphabets to be 26. Now the probability of picking an F, the probability of picking an F is 1/26. That is the probability of picking an F. Now the probability of picking F or T will now be 1/26 plus 1/26. So we solve where we have 26, we have 1 plus 1. This will now be 2/26, where we have this to be 13, 1/13. So the probability of picking F or T is 1/13. Now the probability of picking one of the letters of the word frequency. Now we have frequency, we count 1, 2, 3, 4, 5, 6, 7, 8, 9. We have it to be 9. So one of the letters in the word frequency, one of the letters of the word frequency will now be 9/26. So we have it to be 9/26. That's probability of picking one of the letters of the frequency. Now, not one of the letters of the word table. One of the letters of the word table. We have table to be 5. So we have it to be 5/26. Now it says not one of it. Not one of it. So the probability of not one of the letters table will now be equals to 1 minus 5/26. We have 26 minus 5. This will now be 21/26. So not one of the letters of the word table is now 21/26. And this brings us to the end of this class on probability, where we've explained theoretical probability and experimental probability, where we also solved examples on this. So do subscribe to our YouTube channel, like and comment, and I'll be seeing you in the next class. Thank you.